Okay. Then we are going to see what are the principles we are using in the Fourier transform and what are the applications which is under Fourier transform. Then we are going to analyze a case. Okay, that is the thing we are going to see in today's class. Okay, so the first thing is we already know the concept Fourier series, right? Now tell me any idea about what does mean by Fourier series?
It's a periodic function, ma'am.
Okay.
It can be used with an intervals, ma'am.
Okay.
Fourier transforms cannot be used for periodic function, whereas it can be used for non-periodic functions.
Yes, the main difference is if we are using a periodic signal, that means the waves which is going to repeat. Okay, that is called Fourier series. But in Fourier transform, this is not applicable. It is a single term, right? So the example, any example for that?
MRI scanning.
Okay. Simply you tell any example, right? Okay. Well, we are sending the voice node, right? So it is a single communication. So we can say which is a Fourier transform signal. Okay. If you want to analyze a signal, we are going to use Fourier series or Fourier transform. So based on the waveform, whether it is going to repeat or it is not going to repeat. Okay. So if it is repeated means we can use Fourier series or it is Fourier transform. Okay. And if you want to convert any time domain to frequency domain, okay, we can use Fourier transform. So that is the main reason we are using Fourier transform. If you want to convert any signal from time domain to frequency domain, we can use Fourier transform. Okay, is it clear? Okay, shall we go for the next thing, which is the working principle? Okay, so Chandni going to tell.
So I'm Chandni, and Fourier series and transform work on the principle of which ma'am told, like they work on the principle of converting sine domain into frequency domain into sine domain and cosine domain. It basically works on the principle of converting any complex signal to sine domain as well as cosine domain, which can be made into simpler waves that can be used for any applications such as loudspeakers and etc. These sine domain and cosine domain are obtained from microwaves and microsignals, which can be cannot be seen when they are naked eyes. So these waves all together form to make a frequency domain, and these domains can be identified by Fourier transforms and Fourier series as well.
Yes, so I am also wondering, right? So both the tools, that is Fourier series and Fourier transform, if you want to convert any complicated signal into a simpler form, we can use this transform. Okay. Yes. So the next thing is we are going to have the application part. Okay. So there are a lot of applications because it is the main part in the signal, right? So we'll have more number of applications. That is we are going to see now. Okay. So the URL he is going to do.
Image processing, spectrometer, quantum mechanics, digital signal processing, image processing, spectrometer, quantum mechanics, digital signal processing, audio conversion, telecommunication.
So mainly we are using in signal processing, right? So that is the main purpose we are using this transform. Okay. So the next part is what? We will have more number of applications, right? So few of them he told, right? So the remaining part, let's say I'm going to yes.
So I'm going to elaborate about the application of Fourier transform. So Fourier transform has a wide range of applications like telecommunication, audio processing, and image analysis. It is widely used in medical fields such as MRI and CT scan imaging. It is also used in wireless communication such as radar system and satellite communication. And additionally, it has a data compression that is used in videos and audio and image compression. And it is digitally, it has more efficient in digital communication. So this Fourier transform remains an essential and powerful tool in many of the technologies today.
Yes, so finally we will have the conclusion part, right? Before that we will have the case, right? So what is the case we saw now, right? Yes? Yes? That is okay, that is we will have more number, right? So we are going to choose any one application, then we need to analyze it, right? So what is the thing we are done now? Finally we said, right? Yes, in digital communication, it just analyze the case based on the transform, right? So this way we need to done a case study. Okay. So we have any clarification? Just shall we recall what are the things we done? Yes. So the first thing is yes, because we already have Fourier series, we are going to extend that Fourier series into Fourier transform. So we should know what is the difference between these two. Okay. So that one is what? Yes, so Fourier series is periodic signal and Fourier transform is non-linear. Okay. Then we saw the working principles, right? What are the principles we are following in these cases, right? The next we saw the application part. So we will have more number, right? So one by one we saw, right? Finally we analyze the case which is based on the digital communication. Okay. Shall we close session?
Yes, sir.
Yes. Thank you guys.
Thank you, ma'am.